Java Lambda expressions are the closest you get in Java to having functions as objects. A Java Lambda expression is actually an anonymous implementation of a single method interface. So let me show you first what an anonymous implementation of an interface looks like in Java before we had Java Lambda expressions. I will implement the standard interface comparator, and I will use it to compare two strings just for the sake of making the example easy. You see, comparator is an interface, so normally you cannot instantiate it, but what happens here is I create an anonymous implementation of the comparator interface. And actually I need to have it typed with string here so that we can have string parameters here. So there you go. This is an anonymous implementation of the comparator interface. I can refer to this anonymous implementation as an object via the variable I assigned the anonymous implementation to, as you can see here, down here. Obviously, for this implementation to do anything sensible, I would have to finish the implementation and return something sensible from the compare method here. And I will just do that. I will return O1 compared to O2, which is the standard way of comparing strings in Java. And I should probably also catch or capture the return value so I can see what the result of the comparison is. And then I can print it out so you can see what the result is, and then I can try to run it and we can see what is getting printed out into the console. As you can see, it says -15, and that is because the second or the first string here is before the second string when compared alphabetically. So that's why it returns a negative number. Now I want to show you what it looks like when you implement the comparator interface using a Java Lambda expression instead. I will still have to type the interface that I want to implement here on the left. And then I can now write the Lambda expression here. And this is the syntax, right? This is the syntax used to tell Java that this is a Java Lambda expression. So let's examine this Lambda expression a little bit. As you can see here, the Lambda expression here starts here and it ends here. What you see here in the beginning is the parameters to the method that it is implementing. Remember that a Java Lambda expression has to implement a single method interface, and the method that is implemented here is the compare_to method from the comparator interface. And so the parameters passed to the Lambda expression are the same parameters that are passed to the single method that is being implemented, or the single method from the single method interface here. So that's string O1 and string O2, and you can see I have written them down here as parameters. Then we get this dash and a larger than sign, which is like together makes up an arrow, and then you get the body of the Lambda expression. This is the function, that is the code that is actually executed when the Lambda expression is called. This is equivalent to the code written in here in the method body of the anonymous method, the anonymous interface implementation up here in the first example. I can now go ahead and actually call the Lambda, and I do that via its method, or via its variable reference here, just like if it was the anonymous anonymous interface implementation. So I will just to show you that the result is exactly the same as with an anonymous interface implementation, I will use the exact same case. Here, and I will print out the result so that you can see that the two implementations of the comparator interface actually result in the same result, or actually return the same result. So now we run it, and you can see here both of them return -15. Lambda expression can be simplified a little bit, and I want to show you how. First of all, because Java 8 has some level of type inference, then the Java compiler can actually see from this method declaration that the parameters O1 and O2 are strings. So actually we can omit those in the Lambda definition like this. Now the Lambda definition has become a bit shorter because we can leave out the parameter types because they are inferred from the method definition in the interface. In cases where the Lambda body consists of a single statement, you can also simplify that a little bit. In that case, you do not need the brackets around the Lambda expression body or function body. You can just have the body itself, and actually the return here, the return statement, is also no longer necessary. Now you can see the Lambda expression has become a lot shorter. It just states the parameter O1, O2, the parameter names, and then it says what has to happen with, inside the Lambda function body. Also have a couple of simplifications possible around the declaration of the parameters of a Lambda, but that depends on how many parameters the method takes that the Lambda expression is implementing. So let me first clean up here a little bit, and let me show you what I mean by creating a new interface which we will use to show the cases here, or the syntax around the parameter declaration. So first I will create this interface. It will have a single method and it will not return any value here. I will just call it apply, because just to choose a name, and then I will show you what it looks like when it has 0 parameters, right? When the method takes 0 parameters. In order to implement this interface, I can now write my function equals to, and then this here, the Lambda body, like this. Now I can now go ahead and call this Lambda like this, apply. Right. Now notice here that because the method in the myFunction interface does not take any parameters, we do not write any parameters inside the parentheses here in the declaration, in the parameter declaration of the Lambda. And let me just run the example and show you what it looks like. As you can see, it prints out hello world just as we would have expected. Because there are 0 parameters, we have to write these 2 parentheses to mark that there are no parameters for the Lambda. But when when the method takes a single parameter, you can actually omit the parentheses like this. Now you can see we get a red line here because the compiler is saying that we have a parameter missing. So let's call this S1, or we can call it text. That's fine. And now we can actually omit these two parentheses because there is a single parameter in the method that the Lambda is implementing. And similarly, of course, because the function body consists of only a single line, we can actually remove these brackets also. As you can see, this works. Now the apply call down here doesn't work. We need now to provide a text. Right, and actually let's make the Lambda actually print the text it receives so that we can actually test that this construct now works. So let me run it, and we should get it the hello function body text printed out as expected. Now let's try to increase the number of parameters to 2. So we have now a text 1 and a text 2. Let's go back to the code example, and you can see now the compiler is complaining that we are missing a parameter, right? So let's add it. But now you also get the problem that because there are 2 parameters, we actually need to put the parentheses around the parameter declaration again. And so now it works. And of course over here I have to now add or change the name of the parameter over here, and then I will say I will just print this text out as well, both of the parameters. Now obviously now I will have to add a second parameter in the call to the apply method, and I will do it just have something like test, and we can run the example again, and then we can see that we get the combination of the 2 strings passed as parameters just like we expected. So only in the case where there is a single parameter for the method that the Lambda is implementing can you omit the parentheses around the parameter declaration. If there's 0 or 2 or more parameters, you have to include these parentheses. As you have already seen, a Lambda can easily return a value. In this example, it's the method that is implemented returns void. But let's say that it actually should return a string, right? So we take 2 strings as parameters and we return a third string. In this case up here, you can see now this the Lambda body is no longer valid because it is not returning a value, right? System out println returns void, so this cannot be used as a return value. So I will just add a method body, and then we will return text 1 plus text 2 with a plus character in between, right? And now I can call this function again. It will still print something out, and it will also have a return value, which I can now inspect. I will do that simply by printing it out. And this is the output we get when we run the function. You can see that first the Lambda prints out the text up here, text 1 plus text 2, and then it returns the exact same concatenation or the exact same string that is returned here to return value, and then we print that out here. So that is why we get the 2 lines down here. Java Lambda expressions are objects, just like an anonymous implementation of an interface are objects, or is an object, and therefore we can pass it around. So for instance, I can create another variable of the same type, my function here, my function 2, my function, and then I can actually call my function 2. and you will get the exact same result as if you had called the first the lambda expression, because it's essentially referencing the same lambda object. Now let's run the example again, and you will see that it is it's showing a different text, of course, because I used different parameters down here. But other than that, it is actually executing the code from this lambda expression that I have defined up here in the beginning. And all I did was to reassign this lambda object, or this lambda expression, to a different variable and call that lambda expression through that variable.